Let's see a problem called multi-stage graph. In this video, I'm going to cover these are the three topics. Okay, and first initially I'm going to cover what is this graph problem. Next, I'm going to discuss about how dynamic programming is applicable. Okay, this multi-stage graph is one of the problem is related to dynamic programming, and here I'm going to discuss about how dynamic programming is applicable to this multi-stage graph problem. And finally, I'm going to discuss about how can we solve using the forward method. How can we solve this multi-stage graph using a forward method? Okay, let's understand what is multi-stage graph. Okay, let's suppose this is my given graph. Okay, containing 12 number of vertices, and multi-stage graph is a directed weighted graph. Vertices are divided into stages. Okay, if you can carefully notice in this graph, my vertex in this vertex 1 is present in the stage 1, and stage 2 contain the 4 vertices, and stage 3 contain the 3 vertices, and stage 4 containing the 3 vertices, and stage 5 contain the 1 vertex, right? And such that edges are connecting the vertices from one stage to the next stage. Okay, if you can carefully notice this, an edge from vertex 1 to vertex 2, I have connected a directed edge. Okay, that is, this vertex is belongs to one edge, one stage, and another vertex, that is 2, vertex 2 is belongs to the next stage. Okay, that is what I have created a graph like this, right? And also, if you can carefully notice in this graph, my first stage and last stage containing only one vertex, right? Okay, and this problem in real time, okay, it's usually useful to represent resource allocation. Okay, normally we have a concept in a operating system. Okay, I'm not going in deep about this operating system concept, but actually it will useful in resource allocation, right? Okay, now we'll see how this problem is related to dynamic programming. And first, before going to discuss about that, what is our objective? First, we need to identify, whenever you are solving the problem, first you need to know what exactly we need to do in this problem, right? Okay, then what exactly we need to do in this problem? We need to select a path which is giving me the minimum cost. Okay, because we have a multiple paths from to reach from source to destination. Out of that, I need to identify a path which gives me the minimum cost. Okay, then also we can call it as, this problem is also call it as a minimization problem or a optimization problem. Okay, right? And now, before going to discuss about the dynamic programming thing, okay, now is it possible to solve this problem using a greedy approach? Yes, let's see what is the how can we solve this problem using a greedy approach. Then what are the drawbacks of using a greedy approach? Then we'll come back to how we can solve this problem using a dynamic programming concept. Okay, and our objective is to find the minimum cost path. Okay, keep in mind, this is very, very important while solving any problem, right? Our objective is to find the minimum cost path, right? Okay, that means we have to start from the source to destination. We need to identify the minimum cost path. Okay, suppose if I will apply the greedy approach, then what I can do, suppose I'm going to start from the source 1, that is source vertex is 1 here. Okay, then what I will do according to the greedy approach, out of all the edges, I'm going to choose the minimum weight. Okay, out of these 4 edges, what will be the minimum cost edge? That is 2. Okay, that means I'm going to choose a path from 1 to 5. Okay, I'm just applying the greedy approach. Okay, and I have taken this path. Okay, and up to 5 I have reached it. Okay, then from 5th vertex to, how can we reach to the destination? Then I'm going to choose the path out of the minimum of these 2. Okay, which one is minimum? I can choose the path with weight 8, because out of these 2 values, 8 is my minimum, right? Then I have reached the vertex 8. Then, and there are 2 more edges present to reach to the destination. Out of these 2 edges, what will be the minimum weight? That is 5. Okay, then I'm going to choose the weight with 5. Okay, and I gone to the vertex 10. Okay, then finally there is only one edge from 10 to 12, that is the destination, and weight of that 10 to 12 is 2. Okay, then overall cost to reach from source to destination here is, what is the weight? That is minimum cost. Here is the cost. I'm not a minimum cost, I'm just calculating the overall cost. What is the overall cost here? That is 10 plus 5 plus 2 that is equal to 70. But if you can carefully notice, is there any other path which gives me the minimum cost than this? Yes, there is a path. Okay, if you can carefully notice this path, I'm just representing here 1 to 2, right, and 2 to 7, and 7 to 10, and 10 to 12. Okay, I'm going to show you with an weighted. Okay, 1 to 2, what is the weight? Okay, that is the cost is 9, and 2 to 7, the cost is 2, and 7 to 10 cost is 3, and 10 to 12 cost is 2. Okay, then overall cost here is 9 plus 2 11, 11 plus 3 is 14, 14 plus 2 is 16, which gives me minimum cost than what we have approached earlier. Okay, that is the drawback of the greedy, right? That means, what is the drawback here? Because it's literally I'm choosing the minimum value every time, okay, but I'm not going to the remaining paths. That is the drawback of the greedy approach. Okay, for solve this problem, what I'm going to do here is I'm going to perform all the paths. I'm going to find the minimum cost for all the paths. Then only we can get to know that which one is the minimum path, right? Okay, let me draw it with all the paths. Okay, then how dynamic programming will be useful to how overlapping subproblems, all those terms I'm going to discuss now here. Okay, now I'm going to discuss about this is my stage 1. I'm just representing stage 2 and stage 3, stage 4 and stage 5, right? I'm going to start from the stage 1. Okay, I'm going to solve a problem P. Okay, right now I'm at the first stage. This value is the first stage, and the vertex is 1. Okay, this is my vertex number, and this is my stage here. Okay, for understanding purpose I'm just writing down here, this is my vertex, right? Okay, from problem 1 to first stage to first vertex 2, we need to solve this problem. We need to identify the minimum cost. Okay, then how can we solve this problem? Okay, that means we can go to the problem to the second stage. Okay, then I can give the edge vertex 2. That means I can give the edge from source vertex to 2. Okay, better we have to give this value here, that is 9, 7, 3, 2, and next one is 4, 2, 1, and these are the weights are 2, 7, and these weights are 11 and 11, 8. Okay, the next stage weights are this is 6, 5. Okay, this is the cost here, and 4, 3, and next one is 5, 6 here, and finally we have 4, 2 and 5, right? Okay, then what I'm going to do, I can choose a path which goes from vertex 1 to vertex 2, or I can choose a path from second stage, third vertex. I can also choose a path, and also I can choose a path from second stage, fourth vertex, or I can choose a path from that is second stage and fifth vertex. I can choose any one of them in this case, right? Okay, then how can we choose a path from second vertex to the 12th vertex? That means I can choose any one of these 3 edges. That is, I'm just writing down here, this is my third stage. Okay, I can choose a path from second vertex to 6th vertex, or I can choose a path from second vertex to 7th edge, 7th vertex, and or I can choose a path from what we can say, that is third stage and 8th vertex. Okay, either any one of the path I can choose it. We need to calculate the multiple path. Out of that, I need to identify the minimum cost path, right? Okay, in this case also for 2 to 3, that is third vertex, right? For third vertex we have 2 outgoing edges. That means I can choose a path, okay, in the third stage with the 6th vertex, or I can choose a path from third stage, 7th vertex, right? That means if you can carefully notice here itself, okay, then I am calculating the same problems again and again. That is, we call it as a overlapping subproblem, right? I hope you understand this, right? What is the concept of here is, my drawback here is I'm calculating the same thing again and again, because I want to find all the paths, okay, to find the minimum cost. To find the minimum cost, I'm going to find all the paths. Out of that, I'm going to choose the minimum one. But here I'm going to solve same problem again and again. That is, we call it as a overlapping subproblem. Overlapping subproblem. Okay. How can we overcome? For that, we can use a concept of DP, right? Okay, that means here I am going to store. Okay, instead of calculating again and again, I am going to store in somewhere. Okay, then whenever I need to calculate this same problem again, I am going to fetch the value from the table itself. That is the main advantage of using a memorization table. That is the concept of in dynamic programming, right? Okay, let's see how can we construct the table here. Okay, here itself I'm going to construct a table here. Okay, and let's suppose this is my given graph, right? Okay, and I'm going to construct a table here, and how many vertices are present in the given graph? We have 12 vertices. Okay, I'm going to give the values here. This is my value. Okay, vertex value, that is right now what are the values? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, right? These are the vertices available in a graph, right? Now I'm going to construct a memorization table like this. Okay, and okay, now I'm going to find the cost here. Okay, I'm going to represent in a cost here, and also which vertex to reach it. Okay, first thing is, okay, I'm coming from the back. Okay, and right now I'm at the 5th stage. I want to reach to the 12th vertex. Okay, there is no way. Okay, that means cost is from 12th vertex to 12th vertex, cost is 0, right? There is no cost to reach from 12th vertex to 12th vertex. Suppose I am at the stage 4, I can reach from 9th vertex to 12th vertex, or I can reach from 10th vertex to 12th vertex, or 11th vertex to 12th vertex, right? Let me erase this one so that we can calculate easily here. Okay, now I'm going to, okay, what is this cost? Cost of this one is 9 here. Okay, now how can we find the cost here? Cost of the fourth stage 9th vertex. Here you need to be very careful while representing this value. This is my stage value, stage number, and this is my vertex number, right? This is my vertex number. Okay, now how can we reach to the destination from the 9th vertex? Okay, the cost will be 4 here, right? There is only one edge, then I can directly give this value. Okay, then I am going to fill this value. Okay, 9th vertex value is, the cost is 4, and I am going to reach the destination with the 12. Okay, then similarly I am going to find the cost of 4th stage 10th vertex value. Okay, there is only one edge, right? Okay, then what will be the cost here? That is only minimum value is 2 here. Okay, the cost from 10th vertex to 12th, that is the destination vertex, is 12 here. Okay, and the cost is 2, and similarly for the 11th vertex the cost is 1 and the destination is 12, right? I hope you understand this, right? What is D here? We are from which path we are going to choose it, and where is the destination vertex I'm just mentioning in that path, in that table D value. Okay, okay, then I'm go back to this stage 3 here. Okay, right now I have 3 vertices present in the stage 3. Okay, now I'm going to find the cost of the stage 3 vertex 6. Okay, and the cost of, I'm going to find the stage 3 vertex 7 and cost of stage 3 vertex 8. Okay, now how will we find the cost of 3, 6? Okay, 3 is the stage and 6 is the vertex. Okay, that is nothing but it is, I'm going to calculate the minimum of, okay, how will we calculate? Because I have 2 outgoing edges. Okay, that is the cost edge. I'm going to add it here. Okay, for understanding purpose I'm just representing cost of, that is the sixth vertex. Okay, cost of from 6th vertex to 9th vertex plus, and cost of 4th stage comma 9. Okay, that is, from here we have already calculated, right? Okay, that is the advantage of by using a table here. Okay, what is the cost edge here? That is, edge weight is 6 plus cost of this one is 4, then value is 10. Okay, or otherwise we can also choose one more thing. Okay, this cost is 10. We can also choose an edge, that is 6 to 10. Okay, from vertex 6 to 10 plus here, then what I am going to do, that is cost of 4 comma 10. Okay, this is the stage 4 and 10th vertex. Okay, then out of these two, which one is the minimum? Okay, I am just calculating here. Cost one is 6, and because edge weight, cost from 6th vertex to 9th vertex is 6, and cost of 4 to 9 I can directly fetch from the table. Okay, cost from the ninth vertex is 4. Okay, then overall value here is 10. And for 6 to 10, okay, 6 to 10, what is the weight? Cost is 5 plus cost from 4 to 10, 10th vertex. 10th vertex, I will go to this table, I will fetch this value, that is 2. Okay, that is value is 7. And out of these two, which one value is the minimum? This is 7 is the minimum. Okay, then I am going to fill this value for this 6 vertex. I am going to cost will be 7 here, sorry, not 4, and it will be 7. And I am going to which vertex? Through which vertex? That is the 10th vertex, because I have chosen this path. Okay, I am going to fill this value here. Okay, now my next vertex present in the stage 3 is 7, right? Okay, now I am going to find the cost from 7th vertex to the destination, right? Okay, that is what I am going to calculate here. Let me erase this one. Okay, the cost from 7th vertex to, I am going to find the cost here. Okay, and how will we find the cost here? The cost of third stage. I am just representing a format like this. This is right now I am at the third stage. Okay, and the vertex value is 7. Okay, I am going to find the cost of 7th vertex. Okay, that is there will be 2 outgoing edges are there, right? That means we need to find the minimum of an edge from 7 to 9. Okay, I am just representing C here. The cost edge weight here, cost of an edge from 7 to 9 plus, okay, that is cost of 4 comma 9. Okay, that is the 9th vertex cost. Okay, similarly I have to find the cost of 7 to 10 edge weight here. Okay, C is nothing but an edge, that is 4, we have to add it. Okay, that is cost of which one? 4 comma 10, right? That is what we have to do it here, right? Okay, then what is the value here? Okay, what is the value of edge weight here? 7 to 9, edge weight is 4, right? And cost of 4 comma 9, then I will go to this table. Okay, the cost of 9th vertex is 4. Okay, then overall value for this one is, if I will choose this path, the cost is 8. Okay, 7 to 10 path is 3. Okay, and cost of 10th vertex, that is 2. Okay, that is 3 plus 2 is 5. Then which one is the minimum? That is 5. Okay, then I am going to fill the table. For the 7th vertex, the minimum cost is 5. And which vertex I have chosen? That is the 10th vertex. Okay, just pull it here, right? I hope you understand this calculation, right? Now we'll similarly I am going to calculate for the remaining vertices. Okay, let me erase this one. Okay, now I want to find the value for the, I want to find the cost of third stage. Okay, 8th vertex, I want to find the cost of 8th vertex. There are 2 outgoing edges, that means we have to calculate the minimum of, then cost edge weight from 8 to 10. Okay, cost edge weight for 8 to 11. Okay, and also we have to find the plus, we need to add from the cost of 4 comma 10. Okay, that is the 10th vertex cost, and similarly cost of 4th stage 11th vertex cost. Okay, then what is the value for cost of 8 to 10? That is, if you can carefully notice, this edge weight is 5 plus cost of 4 comma 10, that is the cost of 10th vertex. Then I will go to the table. The cost of 10th vertex is 2, because 5 plus 2 is 7 here. And what about this 811 edge cost is 6 plus the cost of 11th vertex, that is 1. Okay, and both are the values are same, then I can choose any one of them. Okay, let's suppose I am going to choose the 10th vertex, let's assume. Okay, or otherwise 11th vertex, you can choose any one of these values because both the values are same, right? Then I can choose any one of them. Okay, for here I am going to fill this value. Okay, the weight here is 7, the cost is 7, and the I'm going to choose the path is 10. Okay, you can choose any one of them, it's fine. Okay, now I have completed the stage 3. Okay, here I am coming, if you can carefully notice what I am calculating here, I am coming from the backward, but I call it as a forward method. I will tell you what exactly forward method is. Okay, let me calculate for these stage values. Okay, and I am going to find the cost of second vertex. Okay, second vertex, how will we calculate? We have 3 outgoing edges, that is minimum of cost edge weight from 2 to 6, cost edge weight from 2 to 7, cost edge weight for 2 to 8 plus cost of 6th vertex, that is third stage 6th vertex, plus cost of third stage 7th vertex plus cost of third stage 8th vertex. Okay, then if you can carefully notice one, what is the edge weight from 2 to 6? That is 4. Cost of 3 comma 6, 6th vertex cost is 7. We have already calculated, that is the reason we have stored it in a table. Okay, then overall weight, this cost is 11. And what about 2 comma 7? 2 comma 7 weight is 2 and the cost of 7th vertex is 5. Okay, then overall cost here is 7. Okay, and next one is 2 to 8, edge weight is 1 plus 8th vertex weight is 7, that is overall weight is 8. Out of 11, 7, 8, which one is minimum? 7. Okay, that is what I am going to fill this table here. Okay, for the second vertex, okay, I am going to fill this value is 7 and which vertex I have chosen here? Okay, that is 7, right? I hope you understand this, right? That is what I have filled it here. Okay, then what about the third vertex? Okay, let me calculate it for the third vertex also as well. Okay, and here I am going to calculate the cost of third vertex, that is cost of third vertex, that is second stage third vertex is equal to how many outgoing edges? There are 2 outgoing edges, that is minimum of cost edge weight from third vertex to 6th vertex and cost edge weight for the third vertex to 7th vertex plus cost of the third stage 6th vertex, cost of 7th vertex, that is third stage 7th vertex. Okay, let me calculate. What is the edge weight from 3 to 6? That is 2 and cost of 3 comma 6, 6th vertex cost is 7. We have already computed, then overall cost here is 9. And what about cost of edge weight for 3 to 7? That is 7 and cost of 7th vertex is 5. Okay, that means this value is 12. Okay, which one is the minimum value? 9. That means I am going to fill this table like this. For the third vertex, my cost will be 9, minimum cost will be 9 and the vertex will be 6, right? That is I have got the output. Okay, I have chosen this path. Okay, then what about the 4? Similarly, I am going to calculate for the 4th vertex as well. Okay, let me erase this one. Okay, I am going to calculate it for the 4th vertex as well, that is cost of second stage 4th vertex. Okay, and that is the reason I am always reading here is for understanding purpose only. I am just reading it is second stage 4th vertex. Okay, and how will we calculate? How many edge weights are there? Only outgoing edges are only 1. Okay, that means you can choose that path, that is C of 4 comma 8 plus cost of third stage 8th vertex. Okay, we have already computed this one, that is 8th stage vertex cost is 7. Okay, and 4 to 8 is 11, then overall weight is 18. Okay, right, I am going to fill it here, that is 18. Okay, and the path we have chosen here is vertex is 8. Okay, because only one edge is available, then no need to calculate, we can directly choose that path. Okay, then similarly I am going to find the path here for the second stage 5th vertex. Okay, that means how many outgoing edges are there? There are 2 outgoing paths. Then how will we calculate? That is minimum of cost edge weight for 5th vertex to 7th vertex and cost weights for 5th vertex to 8th plus cost of third stage 7th vertex and cost of third stage 8th vertex, right? And what is the weight here? Okay, cost of 5 to 7 is 11 and cost of 7th vertex is 5. Okay, overall cost is 16 here and cost of 5 to 8 is 8, right? And cost of 8th vertex is 7. Okay, then overall cost is 15. Which one is minimum? 15 is the minimum. Then I am going to fill this value, that is 15. Path value, minimum cost path is 15 and which vertex we have chosen? 8th vertex. I hope you understand this, right? And finally we have only one thing is remaining to fill in the table. Okay, what is that one? Source vertex. Okay, let me calculate that one as well. Okay, cost of 1 comma first stage first vertex. We have 4 outgoing edges, right? That means here I am going to write it down here, minimum of cost edge weight from first vertex to second vertex and cost edge weight from first vertex to third vertex and cost edge weight from first vertex to fourth vertex and cost edge weight from first vertex to fifth vertex, right? Plus we need to calculate the cost of the second stage second vertex and cost of second stage third vertex plus cost of second stage fourth vertex plus cost of second stage, fifth vertex. Okay, let me calculate here. The edge weight from first vertex to second vertex is 9, and the second vertex cost is, I will go to the table and the value will be 7. Okay, the cost which we already computed earlier. Then the overall cost here is 16 here, and the next cost edge weight, okay, that is 1 2 3 is 7, and the cost of third vertex which we already computed earlier, that is 9. Then overall cost here is 16. Okay, and 1 to 4 edge weight is 3, edge cost is 3 plus, and fourth vertex cost is 18. Then overall cost is 21, and the final vertex, that is cost edge weight vertex cost is 2 plus fifth vertex cost is 15, overall cost is 17, right? Okay, out of these things, which value is minimum? That is 16. We got the two outputs, right? Minimum cost is 16, but we can go through either second vertex or third vertex. Okay, for that reason I have just drawn right lists, right? Okay, but what we have done here, we have computed the value from the back to starting, right? But what we have done as of now, we have just computed the value, but we haven't taken the decision, because that is much more important, right? Which path we have to choose, the minimum cost path, right? That is what we have to going to choose it from the forward way, right? That means we have to start from the source vertex. How can we choose it? I will go to this table. Okay, I have to choose from the first vertex. Okay, then I can go to destination, maybe second vertex. Okay, let's suppose I am going to choose the path of second vertex. Okay, second vertex. Okay, second vertex, I will go to the second vertex. What is the path I can go there? That is seventh vertex, which we already computed earlier. Okay, then I will go to the seventh vertex. Seventh vertex path will be the next minimum cost vertex is 10. Okay, then I will go to the 10th vertex. 10th vertex next path will be the 12. Okay, this is one of the minimum cost path if I want to traverse from the source to destination. Okay, then what will be the weight here? If you can carefully notice, 1 to 2 is 9, 2 to 7 is 2, and 7 to 10 is 3, and 10 to 12, that is 2. Then overall cost is 16, and there will be one more path we can also choose it, right? Okay, let me draw it here, whatever the path we have chosen right now, that is 1 to 2 and 2 to 7, right? Okay, better you can draw it in a different color here. Okay, 1 to 2 and 2 to 7 and 7 to 3, 7 to 10 and 10 to 12. This is the one of the shortest path we can reach from source to destination. But we can also choose one more path, right? We got the minimum cost path is also if we can choose the third vertex also, we will get the same path. Okay, then how can we write it? That is, first I am going to choose the first vertex to go to the third vertex. Third vertex to, okay, then third vertex to, I can go to the sixth vertex. Okay, and sixth vertex to 10th vertex, and 10th vertex to 12th vertex. There is one more minimum cost path here. Okay, that means I'm going to drawn here, that is the minimum cost path is 1 to 3 and 3 to 6 and 6 to 10 and 10 to 12. There is another path here. Okay, this is the another path here. We can go from source to destination. Okay, and also I'm going to, in a book format, the formula will be look like this. Okay, that is cost of, I'm just writing down here. Okay, and whatever the things we have computed, I'm just writing down in a formula here. That is cost of ith stage and jth vertex. I'm just computing the cost of this jth vertex is equal to what I have done, that is minimum of C, cost edge weight from jth vertex to lth vertex plus and cost of I plus 1th stage to the lth vertex. Okay, that is what we have computed, right? Okay, and j comma l is belongs to the edges here. Okay, E is nothing but edge here, and L belongs to Si plus 1. Okay, that is the next stage value, next stage vertex here. Okay, that is what we have computed earlier. Okay, and why we call it as a forward method? Because we have chosen the path decision. At the end we have to take the decision, right? Which path we have to go from source to destination. That is what we are going to choose from the forward way. Okay, that is the from source to destination only. That is, we call it as a forward method, right? I hope you understand this algorithm, right? Okay, and